Okay, so we had an introduction to replicators last week, and I want to show you how you can take something as simple as a string of characters into this ASCII effect, which we have seen lots on the internet. I'm just doing this to reinforce the replicators component that we looked at last week. The first thing that we need to do in this network, and I'm just going to go ahead and mute this so we can start building from scratch. The first thing we need to do in this network is we need to separate all these letters so we can feed those to a text top and replicate them. We're going to make a little chain of dats to separate these characters. So let's start out. And the first dat we're going to make is called a convert. And so what we can do with the convert is we can take this, which is just a string of text that I have from a text file, and we can convert it into a table of some sort. Now, in this case, we have this split cells criteria. So basically, it's going to split cells at /t. We basically need to identify something that we can use as like a delimiter to split. In this case, I just want to use a space because all of these letters are nicely spaced. So if I'm just going to press my space bar, creating a space, I have now separated all of my letters. So we have all these letters are now split, which is great. And each one is in its own table index. I also want to transpose this so that I'm working with the table in a vertical format versus horizontal. It doesn't really make that much difference, but it will be important in how I'm referencing these pieces of data. I'm going to pull out to a null, and I'm going to call this text vals. And so this is going to be the end of my chain that I'm going to reference in my text top. So for text top, let's make that. And right now we have this text saying derivative. We're going to input a little expression in here. So I'm going to say op text underscore vals, which is the name of this operator here, which we've labeled. And then in square brackets, I'm going to say me.digits because we want to access the first value of this text operator, and then 0 because obviously we don't have multiple columns. And it's important to put this into your scripting mode. So let's do that. Okay, so now we have a B. Right now our text is labeled text 1, so we could label that text 0. Text 10, it's going to match whatever we put in there. I'm going to label this just alpha 0 so that we can start at A. A few things we can do here is I want to go to font. I want to select auto fit always, so it's always going to be fitted nicely to that screen. If you want to, you can up the resolution, but because we're using these as smaller pixels of a larger system, I'd recommend just keeping it fairly small. Okay, so now we're ready to link this into a replicator. So let's bring in a replicator and let's drag this in as our master operator. Let's say operator prefix is alpha underscore. So that means everything's going to have the same labeling. And like we looked at last time, we can reference by number or by table. So in this case, we have a table of text vals. So I'm just going to drag that into my template dat table. And we're going to see that we have a bunch of text vals that have been created. I am going to arrange these into a position that makes sense for me. Okay, that feels okay. In terms of copying these replicators, we can see here that we're not copying over that first channel, and that's due to a couple of things. Partly, all of these replicators have the same name, so that means that obviously we couldn't have another alpha underscore 0. So let's just do alpha C for this operator prefix, just so it's slightly differently named. And we can see that it's kind of added to it, but just in terms of the name. So what we also need to do is check this ignore first row, which automatically assumes that there's a header, so basically like a title in your table. And so it's going to ignore the first row automatically. But if you toggle that on/off, you can see that we add 1 to our output. So we get our A if we choose to ignore the first row and have that off. So ignore first row off, which I guess would mean don't ignore the first row. Now we've created all these text operators, we need to connect them to something. And the perfect tool in this case is a switch, which will allow us to feed all of these into a texture 3D, which is what we're going to use in our texture mapping instancing section. So obviously you can select and drag all into a switch. But if I, for example, change my replicator setup by pressing recreate all operators, that's going to disappear. So we're going to reuse that bit of code we used previously to automatically connect to that switch 1. So I'm going to right click on my replicator callbacks, and in this onReplicate function underneath the c.par.clone, I'm going to say c.output connectors, important to have a capital C there, in square bracket 0, and we want to connect that output to our operator that is the switch. So we're going to say open bracket op switch 1 close bracket, and that should allow us to reconnect to the switch everything. Basically anytime there's a change, which is going to be really useful for us in case something happens to our network and we lose all those connections and have to go back into the patch to connect them all. Not ideal. So what we want to do now is we want to plug in this switch into a texture 3D, and this texture 3D is going to fill up with all of the letters in our alphabet that we're going to instance as our texture. Right now it has a cache size of 32, so what we can do is we can just reference that table length again. So we can say op text underscore vals dot num rows 62, so we're going to have a cache size of 62. The nice thing about having that kind of little expression is that it's going to be dynamic, so if you change your table length it will grow or shrink. So we're nearly there in terms of getting this texture 3D kind of populated. We have to do one more little bit of coding to actually place all those letters into that texture operator. And so this is going to be in our index for the switch. So we're going to use a little expression that says me.time.frame -1. And then if we click prefill, if we pulse that prefill, there we go. So we actually have to turn prefill on. My mind went blank there for a second, but if we turn that prefill on and hit pulse, we're going to have everything that we need. So we're going to have A, B, C, D, E, F, G, etc. We can see everything is populated. In this kind of case, I would probably choose to encapsulate all of this and have this kind of collapse down into a base so it's not quite so visually messy on my screen. Now we've actually got this information that we need. So what I'm going to do is select all of this with that out attached. I'm going to right click and say collapse selected. And I'm going to call this ASCII characters. And I always seem to spell ASCII wrong. Anyway, regardless of my spelling, we now have all these characters that we can go in and use in our system. So we're going to look at building our instancing network next. For our instancing setup, I want to create a UV. So I'm going to select a ramp. I'm going to plug that into a flip. And I'm going to select the flop on that flip to bottom left. plug into a reorder and the flip into the second inlet and change that to input 2 for green. Right now I'm just going to keep it as is. I'm going to plug this into a null and I'm going to call this pos. Now what we can do is we can start making the blocks that we're going to actually instance. So I'm going to make a SOP rectangle. I'm going to plug it into a transform and then into a geo. So obviously we can start using this uniform scale to make that transform of that little square smaller before we start copying it many times. But something that I find as a kind of a useful way to get things the precise size that I want is I'm going to go to this ramp and I'm going to reference that resolution in my transform. So I'm going to say 1 divided by op ramp 1 dot width. And then you get like a tiny number, but it's going to more or less scale. Obviously, in this case, I'm working in just a square grid. If you're working in a different resolution, you're going to want to use these scale X and Y parameters so that you actually have something that's scaled more appropriately. But now I can go in and I can instance my position. So let's go in X and Y. Cool. In this case, it's also off center slightly. So what I'm going to do is I'm going to go in here. I'm going to use a math just because I prefer working with things that are centered around the 0, 0 rather than having things at the bottom left. This is just a personal thing. So you can flip this around however you like working with cameras. And for me, an easy way to readjust that is just to say minus 0.5. And we can see it's kind of clipped there. So it's also important for us to go into our first object and say 32-bit float RGBA. And now we can see that this is centered around the middle of our XY00, which is great. So when I bring in the camera, I can just zoom in and out without having to flip between perspective and orthographic. On the note of cameras, let's make a camera and plug it into a render. You can see right now we're in the center of the screen. And what else do I want to do? I want to create a constant that I'm going to plug on there. In terms of my output, I want it to be 1280 by 1280. Doesn't have to be, but I want my thing to be kind of flush square with the sides, so I'm going to play with that and keep everything in perspective. Oops, that's my old one. Just going to go ahead and delete that. And now we're going to just have a null to visualize this output. Okay, so we have, right now we have a white square. In terms of this transform, if you want to, you could play around with this to create things that are a little bit more flush. Or sorry, this is fully flush. In terms of this transform, you could play around to have a little bit more space between these squares if you wanted to. In that case, what you could do is you could say plus, and then you can see all these little squares are not quite touching each other. So you could play around with adding an offset, but for our case, I want everything to be nice and flush. So I'm just going to go back to just having the 1 divided by the op ramp width. There we go. And I'll zoom out again. So now I can actually start putting some kind of texture on this surface. So to start out, I'm going to place my null one on my color map, and we can see we have that texture looking a little crazy right now. So now we are ready to try and texture this with our ASCII inputs. Now, in terms of the two elements we want to use here is we obviously have our characters, which are held in that texture 3D. And I'm just going to label this letter. And we want something that we can apply as a selector, essentially, to select which one of those letters we want to use. In this case, we're going to start out with a noise. I'm going to keep it real simple and just pull up that period to about 4 and not do anything else right now. I'm going to plug that into a null and call that lpos, so I guess letter position. So we're going to start out by dragging our letter to our color map texture, and we're going to see it's not looking particularly nice, and that's totally fine because right now we're just referencing that whole texture, right? And so it's going to look pretty squished and messy. So what we want to do is we want to go in with this lpos, and we're going to use a new part of the instancing tab that we haven't used before, so instancing 2. And so we're going to use the texture coordinate op. So I'm going to drag and drop lpos to our texture coords. We've already assigned our u and v, so we now just want to work with our w. And so I'm going to select our red channel. And now we can see, as I zoom in, all of these are actually doing something. We have a bit of a weird superposition effect here where several things are layered, but we can work that out later. I'm going to animate this with an abstime.seconds. And you know what? 256 by 256 in this context is kind of big for a grid. So we've already placed things into a container before. So to keep things nice and simple, I'm going to go ahead and place things in a second container so we can add some parameters. Right now, basically this noise is our texture input. So what I want to do is actually have it outside of our component, so we can basically connect any item we want to control the ASCII text. I'm going to collapse. I'm going to call this ASCII. And I'm going to go in here, right click and say customize parent component. I want to create an integer that is going to allow me to basically define my grid size. And I'm going to call it grid res, and for the label grid resolution. So now on these parameters, I can say parent.par.gridRes, and right now it's going to be pretty small. So let's go and recustomize that. And we want to put some range minimums and range maximums. So let's say maximum is going to be 256. We can leave the minimum as 0, although it's probably better not to go to 0 with this because then you just get nothing. And then I want the default to be 50. And we can see, because this is now a different scale to our other texture, that's also providing an issue. So we wanted to scale lpos as well. And so same thing. In terms of this, we'd have to go outside and scale our input, but I'm just going to insert a fit, so it's automatically whatever we put in is going to scale nicely. And we'll just do parent.par.gridRes, and we can copy that. So now we can see this is ASCIIing a lot better, and basically we can plug in any type of input we want to this component. So we have this little drag and drop component now, which is really cool. So if I change the color on this, it's probably not going to change that much because we're just reading that red channel, but let's bring in a video device in. And we can see that that's changing. Something else we might want to do is switch this fit to fit outside, so things will scale more nicely. And a second thing I kind of recommend doing is having a layer that we can bring in. We could see earlier how I had this color layer underneath. So let's quickly do that. So we can just re-instance everything in another geo. We're going to get some weirdness. So I'm going to bring a geo here. This is getting a little messy, so we might tidy that up later. But the geo is going to go there. We're going to instance it the same as we did before with our pos, R, and G. And we can see now that we're basically overlaying. So before we actually do anything, we can just play with this and say we only want to render geo1 with this first render. We're going to overlay the color position later. For the second geo, we will texture it with a constant, and in our second channel, we're going to go in and we're going to use our color op for our LPOS. So this is basically our position, right? And so we're going to do R, G, B. So now we can see we have a sort of a tessellated grid. The reason we want to do this is because right now we're instancing all of these squares. If I was just to texture this constant, we would just get one color. Let's just see what that looks like if I just texture the constant without that layer. We're basically just copying that texture lots and lots of times. So we want to make sure that the constant is just providing us a clean light. In this case, we're not using a Phong. And then this LPOS is giving each of our rectangles a color. If I copy this render and select Geo2, we now have a copy of our second geo that we can bring in, and we can essentially composite these together. And I'm just going to do an over operation. So now you have the text in the middle of your screen. Okay, zooming out. And this is something that you can now just drag and drop anything into, which is kind of super cool. You have a grid resolution here, so you can change how dense that resolution is. You could also parameterize this a little bit more, so you have elements to basically control whether or not you're bringing in this other texture. And you could also have an element where you can control the camera. To show you how that might be done, let's just go and do that real quick. So for camera control, the best thing to control is the FOV angle in this setup. I'm going to drag it to my component editor, bind new par as master. And let's say I also want to just control the opacity of this render too. I could add in a level, and in my opacity on post page, drag that in, bind new par as master. What's good about this is this will apply internally and externally. So if I split my screen, go out a layer, and look at these components here, if I move my opacity on one panel, it will move on the other, and likewise. So this is a kind of a cool little trick to make sure things are all linked. And now you have your very own ASCII component. Some other cool things you could do with this technique is to expand it beyond the grid. So if we go ahead and make a little feedback system, I'm just going to add a feedback. I'm going to plug that into a noise in both inlets. I'm going to turn my output to just noise, my monochrome off, offset down to 0. My amplitude is going to be like 0.025. Don't worry, we're going to expand that out. I'm going to place in an add, going to connect that to the feedback, and then I'm going to drag this pos back onto my target top. And let's add in a keyboard in, There we go. And we could add in a cross as well, just to quickly blend this back to its original place. Let's play with that slightly. Okay, and a final thing, I'll make this noise bigger in the period, and I'll do the classic abs time dot seconds times 0.2. So now you could think about like expanding this network. So you could have it be manipulated, and those targets are still matched up to various inputs. So let's see if I put in my video device. We now have the texture of me manipulated over a bunch of space.